Hey Blue Jays, Mr. Teague here, and I am going to go over today in class. We watched a video from Generation Genius on histograms and box plots, and I've actually put the link for that video in Canvas, so if you want to go watch it again, you can. And then I'm going to go over the extended practice that we did in class so that you fully understand what's going on there, okay? So here we go, histograms and box plots, and this was the extended worksheet that we did in class. See if I can figure out which way is upright. Let me zoom in a little bit here for you. Is that too much? I don't know. Let me fix that. Okay, let's go over a little bit. Okay, so number one, we have this set of data right here. Okay, and so it says the scores from one class on a math test, and here's all the data. And actually, if you count it, there is actually 36 different pieces of data, okay, and we're going to take that data and we're going to create a histogram with 5 bins and a histogram with 10 bins. So if you don't really know what I'm talking about, definitely go to Canvas, watch that video, and then I think you can do this sheet a whole lot better, okay? So the first thing we need to do is we need to divide this data. It says on a separate sort the data into 5 bins and sketch a histogram of the data. So the first thing we have to do is if we have 5 bins, we have 36 pieces of data, then that means we're going to have 7 separate bins, and one bin is going to have 8 in it rather than 7. So if we go and we separate this data, right, this is all in sequential order. So we're going to go from 18 to 52, then we're going to go 55 through 62, and then we're going to go from 65 to 73, and then we're going to go from 75 to 79, and then we're going to go 1, 2, 3, 4, 5, 6, 7. Yeah, then we'll have this, okay? So this is bin number 1, bin number 2. This is 3, 4, and 5, right? And I have already done this, so I can kind of show you what we're going to do. So if I take that data, I'm going to put my paper over here, and I'm sorry I'm not a very good drawer. Okay, but here's my first bin, 18 to 52, 55 to 62, 65 to 73, 73 to 79, 80, 82. So this is the bottom part of my graph. Okay, here's my bin. So then I'm going to count up all the data that I have that fall in this range from 18 to 52. So if I go back to my strand of data right here, right, I have 1, 2, 3, 4, 5, 6, 7, right? So I'm going to draw a line going from here because I have 7 pieces of data up here to 7, and I'm going to draw a bar graph, okay? Because I have 7 instances of that, right? So this is my first bar. My next bin is from 55 to 62, right? And I have 1, 2, 3, 4, 5, 6, 7. So I want to draw my bar graph up to there, right? So there's my next bar. And then 65 to 73, and I had 70 of that. And then 73 to 79, I had 7 of those. And then 80 to 82, and I actually had 8 of those. So this is actually a little bit taller, right? And I'm going to color that in. So now I've separated my data into 5 bins or 5 buckets, and then I've got my bins here along the bottom, and I have the number of pieces of data that I have over here. Okay, let me move that up a little bit more for you. So that's what you would get. Okay, So now let's look what the next question is. It says, on a separate piece of paper, sort the data into 10 bins and sketch a histogram on the data. Okay, so now if I took that and I separated it into 10, if I take 10 into 36, it's almost like 3.6, right? And so if I did that, I didn't keep track of that. So anyway, I would go 1, 2, 3. Well, actually, let's just look at my graph. So here, if I move this down, right, I have 18 to 48, 49 to 52, 55 to 60, 61 to 62, 65 to 66, 69 to 73, 73 to 77, 77 to 79, 80 to 81, and 81 to 82. Well, I have 3 in this category, in this bin, so that's it. In this 49 to 52, I actually had 4. 55 to 60, I had 3. 61 to 62, I had 4. 65 to 66, I had 3. 69 to 73, I had 5. 73 to 77, I had 3. 77 to 79, I had 6. And 80 to 81, I had 5. And 81 to 82, I had 4. So this is my 10-bin histogram. It doesn't look very pretty, but that's what it is. I have my bins along the bottom, and I have my numbers here. And then I count my data, and then I create my bar graph. Okay? Okay, so we've done A, we've done B. It says, which histogram do you think represents the data better? Well, let's look at the data again. If we look at it, this doesn't really tell us anything. They're all about the same length, right? It doesn't really tell us anything. But if we look at the second one, right, at least we have some variation, right? And we can tell we're sort of the same, but it helps us to distinguish maybe these taller pieces of data. These taller pieces of data are mixed in up here, and we can't identify them. But in this one, we can kind of pull that out. So that is helpful when you have it into 10 bins. But depending on the data, you have to decide which illustrates your data better. So I'm going to say on this one that the 10-bin histogram is better. Okay, so we've done that one. D, are there any outliers? Well, when you look at a graph like this, right, you're not seeing the individual. Yes, they've given us the individual data up here, but from the way we've graphed it on the histogram, we can't really tell. Like this column right here, I don't know if there's a 19 in there. I don't know, I don't know. I just don't know, because it's this whole range. So this whole column represents 18 to 52. That's a great big range. I don't know what's there, right? So I can't really identify an outlier from this graph right here. So a histogram is not very good for showing you an outlier. So we're to the question of, are there any outliers? We're going to go, we don't know, because of the graph is displaying a range, right? It's not really giving us each individual data point. And it says, how do you think the class did on the test? Well, looking at it, I would say they probably didn't do very well, right? I mean, here there was only like 8 that did 80 to 82, and there wasn't any 90s or 100s. And they're all sort of mediocre right here. So I would say they did not do well. They did not do well. Okay. Okay, let's go down to number 2. Now they gave us a new piece of data. It says the ages of the employees in Kathy's office, and they give all this list. Now, as you notice, this data is not in order, right? And the first question they ask us is median. So I went and wrote this on another piece of paper, and if you count these up, I actually have another thing I want you to do with your data is count up how many pieces of data you have. If it is an even number, then you may have a median that's between two numbers. I'm going to write between two numbers. If it's odd, you will have a single number. Have one number. Okay, so if we count this, I notice that I have 22. Okay, so I'm going to have something that's in between, unless I have two numbers that are really close together, or the same number. Okay, so if I take that data and I'm going to slide this piece of paper over, I did the same, those same numbers. I guess I need to make it smaller. And I put them in order from least to greatest, so I can identify the wow, I need to go down smaller. Wow. Oh. Okay, so I have 22. I did put them in order from least to greatest. Okay, so what you're going to do is you are going to start at the ends. So like here, see here's 61 and here's 23, and what I'm going to do is I'm going to work my way toward the center, and I'm going to move my finger. So like see here I'm 23 and 61. I'm going to go to 59, and I'm going to go here. See, as I'm moving into the center, then I'm going to go 58, I'm going to go over here. I'm going to go 55 and go over here. And then 54 and 37. And then 51 and 39. Then 50 and 40. Then 49 and 40. 44 and 41. 44 and 42. And then I come here, right, and I don't have a number there. That's because I have an even number of numbers. But what's right there is 43, right? If I'm between 43 and 43, well, it's going to be 43, okay? So my median for that for this set of data is 43. Now it says, how old are the youngest and the oldest employees? Well, if you look at my data, my smallest number is 23, and my biggest number is 61. Okay, so we answered A, we answered B. Now we have C, okay, and C says, we did this of 43, we did this of 23 and 61, and then it says, what are the lower quartile, upper quartile, and interquartile range? And what I'm going to do is I'm going to draw this box plot first, because I think it's easier to get that information, okay? We're going to come back to that. So I'm going to move this paper down a little bit, okay? And the first thing you're going to do when you're doing a box plot is you're going to draw a number line like this. On this, to the far left, you're going to put your smallest number, so we're going to put 23. To the far right, we're going to put our biggest number, which is 61, okay? We know that our median, or middle, matter of fact, let me write that on here, okay? Our median, which means middle, so I want to put that right here, is 43. So let me stop for a second. So if we have median, it means I want you to think of middle. So to find the middle, you have to put it in order from least to greatest, and then you're going to count your way in. You have to remember whether you have an even or odd number. Okay. Mode, I want you to think of most. So what number do I have the most of? Now they are not asking that question here, but if I were to look at my data and figure out what my mode is, I have a couple of numbers, and you can actually list your mode. I'm going to actually put our median is 43. You can actually have a couple of numbers that are the mode. So actually in this set of data, you could say a 40 is a mode. You could also say 43 is a mode, and you could say that 44. You can have more than one mode. Okay. Then we have median, mode, and mean. So mean is the same thing. I want you to think of average. So if we added all that up and then we divided by 22, we would get an average. And to be honest, I didn't do that on this one, but I'm going to do another video. Okay. And then another term or piece of data is called range. And the range is the distance from 23 to 61. And what you do is you take 61 minus 23, and let's see what we get. 61 minus 23. What? 61 minus 23 is 38. So in this example, 38 would be our range. Okay? Our average, we would take all these numbers, add them up, and divide them by 22. So we would divide this by 22. And that would give us our mean or our average. Okay? So we have, back to the box plot. We have 23 here. We have 61 over here. We have our median right here, which is in the middle. So now what we're going to do is we're going to find the lower quartile. Okay? Well, the lower quartile is, we're going to find the number that's in the middle of 43 and 23, right? So if I have this data again, I'm going to go 43, I have 43 and 23, and I'm going to count my way in. So I have 23, 43, and I keep moving forward, and I have 39. Okay, so my lower quartile is midway between my middle and my end, so that's 39. So right here in the middle, I'm going to put 39. This is my lower quartile. Okay, or you could call it, well, I'll display that later. Okay, so then to find your upper quartile, you need to find the middle of 43 to 61. So now you come back to your data, you go to 61, what is it, 61, 43. So we're going to start here at 43, we're going to go to 61, we're going to move our way in, and we find that our upper quartile is 50. Okay, so we have our lowest number, our biggest number, we have our median, which is the middle, then we find the middle between here, which is 39, then we find the middle between here and here, which is here, and then what we're going to do is we're going to draw a line right here, and then we're going to connect them across. Okay, and we're going to put a little line here, and we're going to go like this, and what these are is what they call the whisker. So we're going to go like this. Okay, so this is the box and this is the whisker. Okay, and now I'm going to just kind of start to label some of this for you. So this from here to here is actually quartile 1. This data right here is quartile 2. This is quartile 3. So from here to here is quartile 3. And this is quartile 4. Okay? So actually from here to here is 25% of your data. from here to here is the other 25% of your data. And this is this is 50% of your data. So considering this data line, all this is 50% of your data. This is the lower part, the 25, and this is the upper part, okay? This number here is called an outlier. Outlier. Okay, and this is considered an outlier. What that means is it's very far away from the main part of your data set. So this is where all the data is, but this one's way out here in left field, this one's way out here in right field. So this is what's called an outlier. If you want to think of outfielder, it's just way out there. It's far away from everybody else. Okay, so this 39 is our lower quartile. This is our upper quartile. Okay, this is our median, right? Okay. Now the only other term we haven't talked about is range. So range is the distance from here to here. So if we take 61 minus 23, that's our range in the data. So all this, if we go all this way, this is the range. And then there's one other term here. This is the interquartile range. And that is the distance from here to here. So if we go I, and they just shorten it to IQR, is from here to here. Now to find the IQR interquartile range is to take this number 50 minus 39, which is 11. Okay, so my range for the whole data is 38. My interquartile range is 11. Okay, so this is what's called a box and whisker plot. Okay, that's it. That's all I've got for this. Hope that's helpful. I know we kind of rushed through this in class, but I want to make sure that you really understood this because you will definitely see this on the STAR test. Okay? Okay, guys. Hang in there, you guys, and I will see you next week.